In section 2.0, we're going to be looking at derivatives and tangent lines. So what I want to do is I want to start with something that we kind of ended on in the previous chapter, and I want to build upon it as we move into chapter 2. So if you'll recall, the slope of a tangent line is equal to m as m approaches 0 of f of x plus h minus f of x all over h. And we looked at this in the previous chapter, and we talked about how when we're going from a secant line to a tangent line, we're getting closer and closer and closer to that point, possibly h distance away. And so we even looked at it, you remember this from early on in the chapter, that we would look at 2 points, say C, and instead of using h, I'm going to switch notation a little bit, and I'm going to do it with delta x. Now, when you're referencing delta x, it's known as like the change in x. You saw this in like algebra pre-calc courses. When you're doing slope, you would do the change in y over the change in x, and you would have a delta y over delta x. Well, we do all that. That notation is just the change between the two. So if we're moving a point closer and closer and we're looking at the change between the two, I'm going to switch notations here, and you're going to see me using delta x, but it's still that h distance away. So if I take my C value and I move this direction, delta x away, the x value for this new point here would just be C plus whatever delta x value that is. Then that means that here, this y value is f of C. We know that. So it makes this y value f of C plus delta x. And so if I look at this point here as an ordered pair, it would be C plus delta x, comma, f of C plus delta x. And then we know this point that we started at, or we're trying to get to, is C, comma, f of C. And so if we take all that into account and we look at the slope of the tangent, remembering what we've talked about before, again, slope, I just said this and wrote it as delta y over delta x. So that would be equal to the limit, because we're doing the tangent, of delta x approaches 0. We've done a heck of a lot of limits and took a test over it. F of C plus delta x minus f of C all over delta x. And I'm switching my notation to delta x not because I want to be difficult or I want to change. That is just what you're going to see in multiple textbooks and moving forward in courses. You're going to see more of that notation with those Greek letters, such as this delta x here. Now you can also note that when you look at this compared to what we already knew, the slope of the tangent line, you can see that we're just switching from h over here to this delta x. And so we can note too, lastly, and we'll go to an example, that C, so where C is any value. And so it doesn't really matter the point that we're at. This one is a specific example on a graph over here to the side I'm calling C, but C is just any value. So anywhere moving along that X there. So here's the question you're going to encounter. It's going to say, find the slope of f of x equal to 2x minus 3 at the point 2, 1. And you've done previous assignments talking about how do we relate pre-cal, how do we relate calculus, and this is the case in point. If I were trying to find the slope between 2 points, I would just do y minus y over x minus x. That's pre-cal. But if I want to find the slope at an exact point, which is calculus, I'm going to have to use this formula here. Now it does not give you any breaks and say use the following formula, so you are going to have to know a little bit as you work through this. So let's just go ahead and move up and begin work on this problem. So I'm going to go ahead and rewrite how we find the slope of a tangent. So that would be the limit as delta x approaches 0. You know, I love a good notation of f of c plus delta x minus f of c all over delta x. Now, for this situation, this 2 is going to be our C value. And so I'm going to take 2 and I'm going to plug it in here. And so what this gives me is the limit don't forget your notation, as delta x approaches 0 of, I'm going to plug in that 2 for c, so f of 2 plus delta x minus f of 2 all over delta x. And so you can see I have a 2 right here and a 2 right here where I had that c before. Now I want to fill in what that means. Well, you can see that f of x was given. So if f of x is equal to 2x minus 3, then that means f of 2 is equal to 2 times 2 minus 3. So let's see, 4 minus 3, so 1. And then we also are going to need f of 2 plus delta x. So instead of x, we plugged in 2. So now instead of x, we're going to plug in 2 plus delta x. Now be careful with your algebra on this one. So this is 2 times 2 plus delta x minus 3. And again, notice your similarities. Here's where your x was and your f of x. I'm replacing x with this whole grouping. So I'm going to replace x with that whole grouping. Now, knowing all of what we did over here in blue, I'm going to move back over here to our equation and plug it in. So this gives me the limit as delta x approaches 0. Now, f of 2 delta x, we already know it to be 2 times 2 plus delta x minus 3 minus f of 2, which we found to be 1, all over delta x. So it gives me the limit as delta x approaches 0. We're going to clean this up. So I'm going to distribute this. This gives me 4 plus 2 delta x minus 3 minus 1 simplifies to a negative 4 over delta x. So I get the limit as delta x approaches 0. Let's see, our 4's are going to cancel. So I get 2 delta x. Now don't do any bad math in your canceling. Now with this one, you can see that I have delta x over delta x. And so I can cancel those as well. And so then that gives me the limit as delta x approaches 0 of 2. And we know from previous things that we just plug that 2 into what we have, but this is just the limit of a constant. So this gives me 2. And so we can see that at the point 2, 1, it would have a slope of 2. Now, as a whole, I specifically did that example because look at the equation. That's the equation of 2x minus 3. So it makes sense that my slope is 2 because the slope of a linear function is 2 all the time. It's just a straight line. So that makes sense. Now, as we move through these, it's not going to make as much logical sense that that is true. But in this case, I wanted to show you, yes, that is 2, and this is why it is 2. So let's do another example with a different equation that's not linear. And so this one, the general form for any point, the slope of a tangent, is the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. So now instead of calling it c on the x, I'm just saying x because we know that to be an x value. So here's what I want to do. I want to take in this example, example 2, and I want to find the slope of x squared plus 1 at the point 0 and, separate problem, at the slope negative 1. But since I'm having to do 2 different points on that parabola, I don't want to have to go through the long process that I did on the previous one twice with all the details. So I'm going to do this in a very general sense, and then I'm going to answer the question of the slope at those points. So let's look at this example here. So I'm going to take the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. And again, instead of plugging in here for x and getting that specific slope at 0 and the specific slope at negative 1, so let's use it for our function, which is x squared plus 1. And so you can see that we know f of x is equal to x squared plus 1. So we just need to figure out what f of x plus delta x is. And like you saw in the previous problem, anywhere we have an x, we're going to now change to an x plus delta x. So this would be x plus delta x squared plus 1. So I'm going to come over here, and so this would be the limit as delta x approaches 0 of f of x plus delta x for our equation x squared plus 1, which would be x plus delta x squared plus 1, minus parentheses, please, x squared plus 1, all over delta x. Now, when you're working with this general form in any given equation, the best advice I can give you is 1, make sure that you put this parentheses right here so that you subtract the whole thing. Then we're going to do some algebra and we're going to clean it up. I told you algebra is what's going to get you in this course. Now I need to FOIL out the x plus delta x squared. And so when I begin to multiply that out, again, x, I'm just going to do some side work over here. X plus delta x squared, reminder, don't shortcut, that's an x plus delta x times an x plus delta x. So you want to FOIL it out, distribute it out, but you don't want to just square and square. So that gives me x squared plus 2x delta x, that's your outside and inside, plus delta x squared plus 1. Now I'm going to go ahead and distribute that negative here, so minus x squared minus 1 all over delta x. Now there are a couple of checkpoints. You're going to do this process over and over for multiple equations, so let me tell you some checkpoints along the way. 1, make sure that you have included that parentheses there. 2, the next checkpoint is you're going to notice that your entire back function is going to cancel. So x squared and negative 1 cancel with this positive 1 and this positive x squared. If they don't cancel, check your algebra. Don't just mark them out because you know they happen. Make sure they mathematically mark out to keep your steps straight. We're going to keep on going. The limit as delta x approaches 0 of what's left over, 2x delta x plus delta x squared all over delta x. Then here's your next checkpoint. You'll be able to factor out a delta x. So that gives me delta x parentheses 2x plus, I still have a delta x there, all over delta x. So that's your next checkpoint that you should be able to factor this one out. The reason we want to factor it out is because these should cancel on top and bottom. You don't show that they cancel until you can factor out. And so then that gives me the limit as delta x goes to 0 of 2x plus delta x. Now we can finally take the limit. So this would be equal to 2x plus 0, so just 2x. So in using this general form, we now have an equation in order to find the slope of the tangent line at any point. So this is the slope of the tangent line at any point, which is really great. So now when I go in this problem and it asks me to find what is the slope at the point 0, 1, then I would just say, well, that means the slope would be equal to 2 times, I'm just going to use my slope equation of 2x, 2 times 0, so the slope would be 0 at the point 0, 1. And my slope at the point, get ahead of myself there, my slope at the point negative 1, 2, that would be m is equal to 2 times negative 1, so negative 2. And so this is really going to save us some time. Now, I know you look back over this and you're like, how in the world does all of that work save us time? Well, can you imagine doing that work twice for the same problem? Whereas now when I go to part A and B, I'm able to just plug it in where I only do that work once. Now, great news, you are going to have a problem like this on your Chapter 2 exam. So have no fear, you're going to get to show me and practice this on your own. Now let's look at a picture of what's going on with this one. If I were to look at this graph, and we know that our graph is x squared plus 1, it would look something like this. And so if I were looking at the point 0, 1, which would be right here, that makes sense that my slope is 0 because that would be a tangent line that's horizontal. And if I were looking at the point -1, 2, it would make sense that that slope is -2 of its tangent, because if I drew the tangent, it would be coming down like this. Now, again, I told you in that previous example, like sometimes it's not going to make logical sense of why would it be 2x or why would it be this, but you're going to see this in sections to come. We just got to build up to it. And so this general form of a tangent is so great. It's going to give us a capability to find the slope at any given point on any given curve. We can algebraically work that out and then plug in the points that we need. Now, life does get harder as we move on from here, but before we move into that, I want to go ahead and define something. This gives us one of the big main concepts in calculus, and it's something known as your derivative. The derivative of f of x is actually equal to what we just worked with. This being able to find the slope at a point, not between 2 points, is your derivative. And so it adds in for us a new notation. We say f prime of x is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. And this is the definition of derivative. And so there is one point on the one question on the chapter 2 exam, and it says using the definition of derivative, and you'll have to work out this long process. Now, we do learn some new notation when you're marking or asking or being told to do a derivative. You may see words like find the derivative, like we see here in this example 3 we're going to get to. Or you might just see the notation and then a blank. And that notation is going to be either f prime of x, and you just put like a little apostrophe between the f and x. That's the one you're going to see the most. You might say dy dx, and that's the derivative of y with respect to x. You know, sometimes we write the equations as y equals, so a derivative notation might be y prime. You might have d of dx of f of x, meaning take the derivative with respect to x of f of x. Or you might have this differential equation notation, and it's a capital D small x of y. And so I want to expose you to all of these different notations because you're not guaranteed to have the same notation or the way it is asked on a question of derivative when you're working through the examples or even on the exam. And again, it's leading into some other stuff we need to do as we move forward, like into chapter 3, chapter 4, into Cal 2, etc. So we're going to be building here. So let's work this next example, and you'll notice example 3 compared to example 2. Example 2 wanted us to find the slope at 2 individual points, but in this one, they just want us to find the derivative. So a general form for all slopes of this curve, and this is the cubic curve. So this makes sense that we would have some kind of equation because that thing's kind of curvy and moving around, so it is going to have different slopes along the way. So this says find the derivative. So first thing I'm going to do is I'm going to write that derivative, definition of a derivative, or this long form here, and we're going to say what is the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. Now, as any given formula, this is not going to be given on your exam, so you do want to make sure that you have this memorized, so you'll have to recall that. But hopefully the more you see it, hear it, do it, the more you can retain it. Now, the next step I'm going to do is we already know that f of x is equal to this. So f of x plus delta x would just be plugging in x plus delta x. So that would be x plus delta x cubed plus 2 times x plus delta x. So good news, we're going to get to do some algebra with this. And let's go ahead and start plugging it in. So I get the limit as delta x goes to 0 of x plus delta x cubed plus 2 times x plus delta x minus parentheses x cubed plus 2x. Again, please always use that parentheses. They're going to make your algebra work out a little bit better for you. Now, we are going to have to cube out this x plus delta x. So let me just kind of move over here to the side out of our calculus problem, and let's do some algebra. So if I'm taking x plus delta x and I'm cubing it, I am saying x plus delta x times x plus delta x times x plus delta x. Now we already know what a squared one looks out. Again, you just do x, that gives you an x squared. When you do your outside inside, you get plus 2x delta x, and then your last gives you plus delta x squared. We did that in the previous problem. Now I'm going to have to do it times another one of x plus delta x, so let me distribute that out. So I'm going to do x times each of these. So that gives me x cubed plus 2x squared delta x plus x delta x squared. Plus, now I need to do delta x times each of these. So that gives me plus x squared delta x plus 2x delta x squared plus delta x cubed. Now if you combine like terms, that gives me x cubed. Let's see, I have plus 3x squared delta x plus 3x delta x squared plus delta x cubed. So let me jump back over here to the red. And so we have this whole thing divided by delta x. Don't want to forget that. So I'm going to take the limit as delta x goes to 0. Now we just cubed that out over there. And when we cubed it out, we got x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Now I'm going to distribute this 2 into here, so plus 2x plus 2 delta x. I'm going to distribute this negative, minus x cubed minus 2x, all over delta x. Now this is going to be your first checkpoint to make sure you're doing this correctly, and I alluded to this earlier. That f of x is always going to cancel for you. So this negative 2x should cancel somewhere, and I can see it's going to be with this positive 2x. This negative x cubed is going to cancel with this negative x cubed. And so I get the limit as delta x goes to 0 of 3x squared delta x plus 3x delta x squared plus delta x cubed plus 2 delta x all over delta x. Here's your next checkpoint. You should be able to factor a delta x out of each of your pieces. So this gives me the limit as delta x goes to 0, and I'm going to factor out a delta x out of everything. So I get 3x squared plus 3x delta x plus delta x squared plus 2 all over delta x. So you can see I was able to factor it out of every term. Now I can cancel on top and bottom. Don't do any illegal canceling along the way. And I'm to the function of the limit as delta x goes to 0 of 3x squared plus 3x delta x plus delta x squared plus 2. And since I now have eliminated that division by delta x, or eliminated the division by 0, I can just plug in. I can finally get rid of that limit notation. So that would be equal to 3x squared plus 3x times 0 plus 0 squared plus 2. And that gives me 3x squared plus 2 for a final answer. Whew, I'm so glad I didn't have to do that twice. But for this one, it says, what is the derivative of x cubed plus 2x? And that derivative would be 3x squared plus 2. And then I can find you the slope at any given point on a curve. Now, it does get cumbersome. The fact even over here that we had to cube out that, and you're going to get used to working with your squareds and your cubes. And I am nice. I do give you one that is not so awful when you're working through, especially on the exam, doing one of these. And you know, I can't give you a ton of these. It is a timed exam. Let's do another example of one, but let's kind of do a special situation. Let's look at example number 4. Let's look at some radicals. When you're trying to find the derivative of a radical, or that equation for the slope at any given point, just be careful with it. We're going to pull some concepts that we've already practiced in chapter 1. Okay, I need to find the derivative. So first thing I'm going to do is I'm going to write the definition of a derivative. F prime of x is equal to the limit as delta x goes to 0 of f plus x plus delta x minus f of x all over x. I would write that every single time I'm doing this. Now, we know what f of x is. It's the square root of x. So f of x plus delta x would be the square root of x plus delta x. So let's see what we got. So f prime of x is equal to the limit as delta x goes to 0 of the square root of x plus delta x minus the square root of x all over x. And here is where we're going to have to do some things like we did in the previous one. Remember when we did limits in chapter 1 and we talked about when we had that radical, we had to multiply by the conjugate, and you saw that on your exam? We're going to have to do that here as well. So that's going to be the square root of x plus delta x plus the square root of x divided by square root of x plus delta x plus square root of x. And so we're going to have to do this here. Now, I am not fully going to multiply this out. I am going to multiply out the numerator like you saw in chapter 1, but the denominator I'm just going to carry along. So this is equal to, just a big long line of equal to's, the square root of. Now, when you multiply this first radical times this radical is going to give me x plus delta x. This first radical times this one gives me square root of x times the square root of x plus delta x. But when I go to the inside, it gives me the negative version of that, so I don't have a middle term. And then the negative square root of x times the positive square root of x gives me minus x. So be careful with that. All over x parentheses x plus delta x plus the square root of x. And again, I'm not going to distribute that out. Cleaning this up, we always say the f of x cancels. Look, that one is going to cancel with that one, just as we have been predicting. So that's my first check mark. I'm at least on the right path here. So I get delta x going to 0 of delta x all over x plus delta x minus square root of x. And then we see, I lost my delta x in the original. I went to go to my next checkpoint of canceling that delta x, but I had my form wrong there. So these delta x's are going to cancel. That's my next checkpoint to make sure I'm on the right path. So the limit as delta x goes to 0 of 1 over the square root of x plus delta x minus the square root of x. And then I'm able to evaluate and find that limit. So it gives me 1 over the square root of x plus 0 minus the square root of x. So that's 1 over the square root of x minus the square root of x. Well, that's one of them. There it did again. Sorry, this was addition. So this is addition the whole way. Sorry for making you scratch your head there. So add this all up. So 1 over 2 square roots of x. And so you can see, even from my mistakes here, it's easy to lose a delta sign or a negative sign. So go a little bit slower than I've been going. Go slow, have your checkpoints along the way, like the fact that f of x canceled here and that your delta x you're able to factor out and cancel. Those are 2 really good check marks to make sure you're on the right path. Okay, let's do another one, and I'll go a little bit slower so I don't make these silly mistakes. So there's our formula, the limit of delta x going to 0. And this time, I want to do this practice. I want to look at finding the derivative of this function. So that means f prime of x is going to be equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. See, didn't mess it up there. I'm going to plug it in, so that gives me the limit as delta x goes to 0 of square root of x plus delta x plus 9 minus the square root of x plus 9 all over delta x. Okay, we are going to have to multiply by the conjugate. Move this over some. And so that means I'm going to be multiplying by the square root of x plus delta x plus 9 plus the square root of x plus 9. And as hairy as this looks, we can do this. So this is going to give me the limit, don't lose your notation, as delta x goes to 0. Now on bottom, again, I'm not going to distribute that out. You can see the reason in the last one that worked out pretty nice for us. Make sure I get my signs correct this time. Okay, this first one times this first one just gives me x plus delta x plus 9. First times last, and this one times the one over there. Those cancel each other, so your outside and insides cancel. Then you get minus x plus 9. Make sure you put that in parentheses. Now I'm going to distribute that negative. That's why you'll make sure you use parentheses. And then here's my first checkpoint to make sure everything cancels. So I have the limit as delta x goes to 0. Looks like just delta x again over delta x, this big grouping. Again, next checkpoint, these two cancel. You want to show each of these checkpoints. There's nowhere in these steps that you want to jump, skip ahead, not show work. And so we just have the square root of x plus delta x plus 9 plus the square root of x plus 9. So I'm ready to take my limit, finally. So this gives me the limit as delta x approaches 0. So that gives me the square root of x plus 0 plus 9 plus the square root of x plus 9. So let's see, that gives me x plus 9 plus the square root of x plus 9. So I got two of them. So 1 over 2 square roots of x plus 9. And so you can see there's my general form for the derivative or slope at any given point. All right, I think we should do a couple more examples to make sure we feel good with this. And so let's do another one. So we've done a couple radicals, we did a cubic. Let's do another square. So this would be, what is your derivative? That's what I'm trying to find. So I'm going to say f prime of x is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. So hopefully you're writing these notes, you're seeing it, hearing it, doing it, you're retaining this. And then I'm going to fill in. So I know that f of x plus delta x is going to be equal to 15 minus that new grouping squared. So I'm going to say this is equal to the limit as delta x goes to 0 of 15 minus x plus delta x squared. You're going to get to square it out again. Minus that whole grouping of 15 minus x squared all over delta x. So you're going to square x plus delta x quite a bit. So this gives me the limit as delta x goes to 0 of 15 minus x squared plus 2x delta x plus delta x squared. We've already done this twice. I'm going to go ahead and distribute that negative. So minus 15 plus x squared. Let's also distribute this negative throughout so we don't forget about it. All over delta x. And then start cleaning it up. It's your algebra that's going to get you. So there's your x squared, and there's a negative x squared. There's a negative 15. There's positive 15. First check mark, we were able to cancel out that f of x. So that gives me negative 2x delta x minus delta x squared all over delta x. So there's your next checkpoint. Can you factor a delta x out of everything? So it gives me negative 2x minus delta x all over delta x. Yep, check mark. I'm able to cancel that. So that's equal to the limit as delta x goes to 0 of negative 2x minus delta x. So that's negative 2x minus 0. So it results in just a negative 2x. Hopefully you're getting a little bit quicker with this, but as always, at any point in the lecture, just kind of pause it, work your step, and then come back to it. Last one, and we'll end this long lecture here. Let's do this squared one here. And so that means I want to find what is the derivative. So I'm first going to find that x plus delta x, so that would be x plus delta x squared minus 3 times x plus delta x. Got a little carried away with my writing there. Plus 2. So I'm going to write my form. F prime of x is equal to the limit as delta x goes to 0 of x plus delta x minus f of x all over delta x. So that's equal to the limit as delta x goes to 0 of x plus delta x squared, this one's a little bit longer, 3x plus delta x plus 2 minus x squared minus 3x plus 2 all over delta x. And this one's going to be pretty. It is equal to the limit as delta x goes to 0. Now I'm going to square that out. So x squared plus 2x delta x plus delta x squared. I'm going to distribute this negative 3 minus 3x minus 3 delta x plus 2. I'm going to distribute this negative minus x squared plus 3x minus 2. It's going to be your algebra that gets you. Can't reaffirm that enough. Now we should be able to cancel the back half. Negative 2, positive 3x, negative x squared, positive x squared. We made it to the first checkpoint. So the limit as delta x goes to 0 of 2x delta x plus delta x squared minus 3 delta x all over delta x. Now we should be able to factor a delta x out of there. There's our next stopping point. So delta x gives me 2x plus delta x minus 3 all over delta x. Yep, we made it. That cancels. It factored and canceled. Equal to the limit as delta x goes to 0 of 2x plus delta x minus 3. And we can finally take that limit. So 2x plus 0 minus 3, 2x minus 3. Woo! But I'll tell you what. If you look at that problem right there, that is beautiful. Those are examples of ones that you're going to see in the homework, but as well as you're going to see one of these on your exam. And I have good news for you. We will not do this forever. I will show you some shortcuts along the way.